In today's lecture, let's talk about a doubly linked list. There are four types of linked list. First one is a singly linked list, then doubly linked list. Third one is a circular linked list, or we can also call it as a circular singly linked list. And fourth one is a circular doubly linked list. In the previous lecture, we already learned about what is singly linked list, and today we are going to discuss about what is meant by doubly linked list and how to represent doubly linked list. So let's start from the basics of a doubly linked list. So a doubly linked list is a two-way list in which all the nodes will have two links. It is a two-way list in which all the nodes have two links. Or the second definition we can create about a doubly linked list is when a node holds a data part and two addresses, it is known as a doubly linked list. When a node holds a data part and two addresses, then it is known as doubly linked list. Okay. Now here there are two addresses, one is a previous and the other one is next. Previous points to the address of previous node and next points to the address of next node. These are the two pointers and the first one is a data part. So this type of linked list is called as a doubly linked list. So in doubly linked list, node consists of three parts. The first one is a data, second one is a pointer to the next or right node in a sequence, a pointer to the next or right node in a sequence, and the third one is a pointer to the previous or left node in a sequence. So in doubly linked list, a node consists of three parts. The first one is a data, second one is a pointer to the next node or right node in a sequence, and third is a pointer to the previous or left node in a sequence. Now let's see the representation of doubly linked list. So doubly linked list is represented like this. This is a node and each node consists of three buckets. The middle bucket is called as a data. The first bucket is called as a previous and the last bucket is a next. So here previous and next are both the pointer variables which points to the address of previous and next node. So the starting node of the linked list is called again as a head, or we can call it as a start, and the last node of the linked list is called as a tail or end. Now again let's see the representation with three number of nodes. So this is node 1, then this is node 2 and node 3. Each node consists of three buckets. Three buckets means three partitions. Okay. Now here this is a previous, the middle partition or middle bucket is a data and this is a next. Again same, this is previous, this is data and this is next. Again previous, data and next. Okay, here this is node 1, node 2 and this is node 3. There are three number of nodes in a linked list. Now here this next, the node 1 next points to the address of node 2 and node 2 previous points to the address of node 1. Again node 2 next points to the address of node 3 and node 3 previous points to the address of node 2. So this is a two-way linked list. Singly linked list is a one-way linked list. So traversal can be performed in one direction only. But doubly linked list is a two-way linked list. So we can traverse in both the ways. Okay. So here the first node is this, that this is called as a head or start node of the linked list. And the last node of linked list is this, so this is called as a tail or end of the linked list. Here for node 1 the previous do not point to any of the node, So the value of this previous is null. There is no any address stored inside the previous of node 1, and here again for node 3 the next points to the null value. That means the next do not point to any other node. That's why the value of next in the last node is null. Now let's see the example of the above representation. So again here I am going to create 4 number of nodes. So this is node 1, node 2, this is node 3 and node 4. Okay. Again all the nodes are divided into 3 buckets or 3 partitions. The middle partition is data, for example 10, 20, 30 and here is a 40. This is node 1, this is node 2, node 3 and this is node 4. Node 1 next points to the address of node 2. Node 2 next points to the address of node 3. Node 3 next points to the address of node 4. Again node 4 previous points to the address of node 3. Node 3 previous points to the address of node 2 and node 2 previous points to the address of node 1. So this is a two-way linked list. Now again for node 1 this previous is null. So we can just cross here or we can write down null, because previous of node 1 do not contain the address of any other node. That's why this is a null. And for the last node the next is also null. Again this is a head or start of the linked list, the starting node of the linked list, and the last node of the linked list is called as a tail or end. So again you have to mention here this is a previous, this is what? This is previous, then this is a data and this is next. For all the nodes in a linked list you have to mention which is previous, which is data and which is next. Now let's write down the code to create a node in a doubly linked list. In a doubly linked list we have a data and 2 pointers. In a singly linked list we have data and 1 pointer, that is a next. But in doubly linked list we have a data and 2 pointer variables, previous and next. Previous points to the address of previous node, next point to the address of next node. So let's write down the code for the above linked list. So first we have to create a structure, struct, and for example doubly linked list, name of a structure as doubly linked list, D linked list. Then first we have to create a data. So write down integer data and there are 2 pointer variables, that is a previous and next, or you can call it as a left and right. So here write down struct, then name of the structure, that is a D linked list, and a pointer variable, that is a previous. And again for next write down struct D linked list and the pointer variable, that is a next. Then end the structure, end with semicolon. Okay, so this is a code for the doubly linked list, creating a node in a doubly linked list. You can use the pointer variables as previous and next, or you can also use a left and right. Now again one thing you have to remember about the linked list is in a singly linked list we could traverse in only one direction, because each node contains address of the next node and it doesn't have any record of its previous node. Okay, we already discussed about this. However, doubly linked list overcome this limitation of singly linked list due to the fact that each node of the list contains the address of its previous node, so we can find all the details about the previous node. Okay, in a singly linked list we could traverse in only one direction, but in a doubly linked list, as there are 2 pointer variables, previous and next, so we can traverse in both the directions. If we want to find out the record of previous node, then we use the previous pointer and go to the previous node, and if we want to find out the record of next node, then we use the next pointer and go to the next node. So I hope you understand all about the doubly linked list. If you have any doubt or any query regarding this topic or any other topic, then let me know in the comment section. I will try to answer your questions.